us solve some problems in the coordinate system transformation. So this is the first problem. Given the point P minus 2, 6, 3 and vector A, y, ax vector plus x plus z, ay vector, s plus the point P as well as A in cylindrical and spherical coordinates. Evaluate A at P in the Cartesian cylindrical and spherical system. So in the problem they have given a point as well as a vector, and both the things are to Cartesian coordinate system. We have to convert this Cartesian point to cylindrical coordinate point as well as spherical coordinate point. Likewise, we have to transform the Cartesian vector to cylindrical vector as well as the spherical vector. After converting the vectors, we have to find out the numerical, find out its corresponding value for this point. We have to evaluate point vector A for this point P. So the point P, let us solve the problem. At point P, our x value will be minus 2, y value will be 6 and z will be 3. It is written here. Now we are going to change from Cartesian to cylindrical and spherical. First of all, we are converting the point. After that, we convert the vector. So in cylindrical coordinate system, the radius rho will be equal to square root of x square plus y square. So radius will be square root of x square plus y square. So instead of x, you substitute minus 2. Instead of y, you substitute 6. So 4 plus 36, you get this value. And pi angle will be tan inverse of y by x. Substitute 6 by minus 2, you get 108.43. And z equal to 3. Z equal to z, so z equal to 3. These 3 refers to cylindrical coordinates. And for spherical coordinates, the radius will be equal to square root of x square plus y square plus z square. And the points are given as minus 2, 6, 3. Substitute those values, you get 7. And another one angle pi, which is same as that of cylindrical coordinates tan inverse of y by x. So the third angle will be theta tan inverse of square root of x square plus y square divided by z. You substitute these values and you get the angle as 64.62. Now we have transformed the point, Cartesian point, to spherical point as well as cylindrical point. The point P is minus 2, 6, 3, whereas the cylindrical point will be 6.32, 108.43, 3. And whereas for spherical coordinates it is 7, 64.62, and the pi will be same value, so 108.43. Let us transform now. We are going to transform the vector as a Cartesian vector to spherical vector as well as cylindrical vector. So the vector is given. Okay. So vector is y ax, that is the x component is y and the y component is x plus z. That's what it is written here. X component ax equal to y and y component ay is equal to x plus z, and there is no z component, so a is equal to 0. For cylindrical system, we have to calculate a rho, a pi and a z, and this is the transformation matrix which I did in the previous class, and this one is the x component, y component, y by x plus z 0. So just multiply and expand this equation, you get a rho equal to y cos pi plus x plus z into sin pi. Likewise, you get 3 equations. So after finding this equation, you have to substitute for y, x and z. For x, you have to write it as rho cos pi, and for y, you have to write it as rho sin pi. We substitute for this equation. Instead of y, rho cos pi. Instead of x, a rho instead of y, you have to write rho sin pi, rho into sin pi. Already cos pi is there, it is written here. So for x, rho cos pi, z is same thing. and sin pi vector is A row. Likewise, you have to expand this, you have combined this equation. Now we have to calculate the vector A value at this point. So for Cartesian system, A will be equal to 6ax plus ay, because we have substituted for, see how we get 6 means, you can see for y you have to put 6ax plus ax minus 2 plus 3, minus 2 plus 3 will give rise to 1. So 6ax plus ay vector only you have obtained here. This is the Cartesian vector value, vector equation at the point P. Likewise, we have to calculate for cylindrical coordinate system at point P. For that point P, we have to calculate the cylindrical coordinate value. So you know the cylindrical coordinate value will be this one, r, pi and 3, that be z. So you substitute to bring this value here. So after finding this value, you can calculate this one. So rho will be root 40, tan pi is equal to 6 pi minus 2. So cos pi means opposite by, adjacent by hypotenuse, and this sin pi will be opposite by hypotenuse. Whereas tan is opposite by adjacent. So for opposite it is 6, for hypotenuse it is 2, and adjacent minus 2, and for hypotenuse it is root 40. So you have find out cos pi, sin pi, rho and everything. So in the previous equation, so you got this, for rho you substitute, cos pi substitute, sin pi substitute for all the quantities, and you simplify the equation, and the equation will be minus 0.9487 a rho minus 6.008 into a pi. Similarly, for spherical system also you write the transformation equation. You know this one, sin, and you can expand this one equation. After expanding, you get this equation. These are just the formulas. So for x you have to write r sin theta cos pi. For y, r sin theta sin pi. For z equal to r cos theta. You substitute these values in the and previous equation. On substituting, you get this equation. So corresponding vector will be ar, a theta and a pi. At point P means for spherical coordinates you have calculated this value. So you have to substitute r, for r you have to substitute 7, for theta substitute this one, for pi you substitute 108.43. So you substitute these values for each and everything present here. So that's what it is written here. Substitute, on substitution you have to find it. This one, this is like this calculation, you know, adjacent by hypotenuse, opposite by hypotenuse. Again for this one 3 by 7, root 40 by 7, because tan theta we have calculated as root 40 by 3. So from that only they have calculated root 40 here, 3 here, the radius will be 7, r value will be coming. So substitute and simplify, you get this equation. So in this equation you can see you get for Cartesian system you get a as 6as plus ay. For cylindrical system you get minus 0.9487 minus 6.008 a pi. For spherical system you get this equation as minus 0.857 and minus 0.4066 minus 6.008. If you find out the magnitude for all the three equations, for Cartesian, for spherical as well as for cylindrical system, we get the modulus value as 6.083. That means the magnitude value is remaining same for all the three coordinate system. If the magnitude value remains same for all the coordinate system, then we can say the field associated with this will be a scalar field. We can have that conclusion. So it is another problem, but what the thing is here, no Cartesian is involving. Here they given a cylindrical coordinate system. From cylindrical they are asked to calculate Cartesian as well as cylindrical. You know the conversion from cylindrical to spherical to Cartesian, as well as Cartesian to spherical. So like from the previous problem, we calculate from Cartesian to spherical. In this problem, we are going to calculate from spherical to Cartesian. This is the matrix, manipulating matrix. So write down this matrix, and here first component 10 by r, second component r cos theta, third component will be 1. So on multiplication and multiplying this thing, the first bx will be this one, and for second thing, for second line we get this equation, and for third line we get this equation. After getting this equation, we have to calculate for these things. So here r will be, radius will be x square plus y square plus z square, which is the formula. Theta is equal to tan inverse root of x square plus y square by z, and pi will be tan inverse of y by x. If you want to find it, sin theta means opposite by hypotenuse. This one is the opposite, so this one opposite, and adjacent will be the radius, so this thing will comes here. And cos theta will be, adjacent will be z by the radius, this one. Corresponding sin pi equal to opposite, here opposite is y, divided by the corresponding radius will be x square plus y square, and for cos pi it is x by y square, root of x square plus y square. So here what we are doing is, for bx, by and bz, we are going to calculate the value at minus 3, 4, 0 for Cartesian, so and for cylindrical we have to calculate here. So for Cartesian we are going to calculate this one, minus 3, 4, 0. We substitute for minus 3, 4, 0 for x, y, z, and if you simplify, we get this equation as, and simplify the equation, we get bx equal to minus 2 and by equal to 1 and bz equal to 0. So now we are going to write the equation b vector equal to minus 2 into ax vector plus ay vector. This one is 0, so we get minus 2 ax vector plus ay vector. That's what we have transformed the spherical coordinate vector to a Cartesian coordinate vector. So we can similarly do for the spherical to cylindrical. Here there is another one formula, you can go through it. So just study this manipulating equation, substitute this one, then multiply these two matrices. We get the first row sin theta into 10 by r plus cos theta into r cos theta plus 0. Likewise we get b rho, b pi and bz. After that, here we have to substitute for r is equal to rho square plus z square, and rho is x square plus y square. Likewise theta equal to tan inverse of square root of x square plus y square by z. So sin theta and cos theta is you can calculate. After calculating sin theta and cos theta, you substitute for sin theta as well as cos theta. Then what we have to do is, we have to substitute this cylindrical coordinates for this equation and simplify. If you simplify, you get 2.467 for the first component b rho, and 1 for the b pi, and 1.167 for bz. So you get this equation. So you have two vectors, one that's Cartesian it is this one. If you find out the modulus for that one and this one, for cylindrical coordinate, spherical coordinate, as well as for the Cartesian coordinate, their magnitude is around 2.907. So it is the manipulation only. We should know the formula. If you know the formula, you can easily do with your calculator. So you have the homework. You should not say it is impossible. You should complete the problem and submit the solved problem within the next class. So first problem will be, you have to convert the points. There are 3 points from Cartesian to cylindrical and spherical. So first point to Cartesian, from all 3 are Cartesian. First point to cylindrical as well as spherical. Here also you have to convert for spherical and cylindrical. Here also, this is a vector. This is a Cartesian vector. You have to convert to cylindrical as well as spherical. And the third, some subdivision will be after converting into spherical and spherical. You have to calculate the magnitude of this q vector at the point at the point t. We should calculate for the point t. At point t, you have to calculate the magnitude of q as well as in spherical coordinates, cylindrical coordinates as well as coordination coordinates. This is the one more problem. Express the following vectors in Cartesian coordinates. So it is given in cylindrical coordinates. You convert into Cartesian equation. This one is AR, A pi and theta. 3 are involved in. So definitely it is a spherical coordinate. So spherical to Cartesian coordinate you have to do. So after doing the problem, you have to solve the problem. And verify with the answer, and the answer is given in the next slide. It is the answer is presented here. While solving, if you have any doubt, any queries, you can call me or message me. Thank you. Have a nice day.